In this video, I'll be covering problems 1 through 5 on the second test review. So number 1 asks you to solve each quadratic equation using the quadratic formula. In order to do that, we have to know the quadratic formula. So remember that it's x equals the opposite of b plus or minus the square root of b squared minus 4ac, where, by the way, this part here, the b squared minus 4ac, is called the discriminant, all over 2 times a. So you may want to refer to your homework sheet that we did with quadratic formula in the discriminant to help you with these problems. Remember that in order to get started, we need to have all of our problems set equal to, or all of our quadratic equations set equal to 0. So if you take a look at A, we do have a positive quadratic term. We always want to ensure our quadratic term is positive. It makes the process easier. And to set it equal to 0, we would need to subtract 2x from both sides, moving our linear term over. When we do that, we would get 5x squared minus 2x plus 4 is equal to 0. To get started with the quadratic formula, I highly recommend identifying your a, b, and c values first. Your a value is b, your c value is -2, or I said that wrong. Your b value is -2, and your c value is 4. And to go ahead and find the value of the discriminant first, meaning the b squared minus 4ac part. I find that students a lot of times mess up on this part here, and in particular it's going to be easy because the b is negative. So it's better to go ahead and find it to get started. Sean, go get me a computer or calculator, please. So we substitute -2 for b. Please remember to put parentheses around that, around your -2. Your calculator would understand that the opposite of 2 squared if you did not. So -2 squared minus 4 times 5 times 4. When you type that in, -2 squared minus 4 times 5 times 4 is -76. So we know this is -76. So that means when we go to plug it into our quadratic formula, we've already got this value. It makes the work easier. Please recognize also that if you have a discriminant value that's negative, we should expect to see 2 complex roots, meaning we'll have I in our answer. So continuing, x equals the opposite of b. Well, if b is -2, the opposite of -2 would be +2, plus or minus the square root of our discriminant, -76, all over 2 times our a value of 5. So at this point, we should recognize when we have square root of a negative, we are going to need to put I out front, make that positive, and if we can reduce the square root of 76, then we have to do that. So on scrap paper here, I'm going to break down the square root of 76. 76 is an even number. A good place to start is always to divide by 2. So we get 2 times 38. And then if we continue to break that down, it's also even. So it's 2 times 19. Okay? So I've got 2 times 2 times 19. Remember, we're looking for pairs. So that means our pair is going to come out. 2 is going to come out. And it leaves the last factor here of 19. So back up here, I'll write 2 plus or minus. Please do not forget your I. All over 2 times 5, which is 10. Then, when you go to simplify it, if there are any factors that these 3 terms outside have in common, you must reduce it. So we should divide each of these by 2 and get 1 plus or minus I square roots of 19 all over 5. All right. For B, it appears is already in standard form, but be careful, it's not set equal to 0. So the first thing we're going to have to do is add 8 to both sides to make it equal to 0. And then we want to, for using the quadratic formula, identify that A will be 1, B is 12, and C is 36. to find the value of our discriminant first, b squared minus 4 times a times c. When we type that in our calculator, we get 0. So with the discriminant of value of 0, that should tell us something really important. If our discriminant is 0, remember that we're going to have one real solution. So continuing here, x equals the opposite of b, plus or minus the square root of 0, all over 2 times 1, which is 2. This is not going to affect our answer because the square root of 0 is 0, and negative 12 plus 0 does not change its value. So we just need to reduce negative 12 over 2, and that should give us negative 6. And remember, we're only supposed to get one real solution when our discriminant is 0. So that should make sense. So number 2, remember I told you to change conjugate to discriminant. And I said, describe how the discriminant helps you determine the number and types of roots a quadratic function has. So what I want you to do is simply explain that when the discriminant is greater than 0, we're going to have 2 real roots. If your discriminant equals 0, you'll have 1 real root. Remember, roots are solutions, x-intercepts, it's all the same. And if your discriminant is less than 0, like we did have for up here for A, it was negative 76, we'll actually have 2 imaginary roots. All right. So next it says find the linear or constant term that would complete the square. That means we're trying to create perfect square trinomials. So hopefully you'll recall this pattern. We did warm-ups and all kinds of stuff with this. But to complete the square, we actually simply take half of b and square it. Don't even worry about the sign. We'll always be adding that number. So when we square half of 7, we actually just get 49 over 4. Now if you type that in your calculator, 7 over 2 squared, math, enter, enter, 49/4. Okay? That's all you have to do. Well, on part B, I'm asking you to do the opposite. So if before we squared after taking half, we want to do the opposite here, meaning we take the square root of 49 and then double it. So that would be 7 times 2, which is 14, and of course don't forget your x for your linear term. And if you recall in class, we would say if this is a perfect square trinomial, if we take half of x squared, the square root of x squared and the square root of 49, which is 7, and if we multiply and double it, we get 14, then it's a perfect square trinomial. So that's what I'm asking you to do here, is use that thinking to help find those terms. So for number 4, it says what value of h is needed to complete the square? Well, this is to let you know that we're trying to find the vertex. So if you think about what we know about the vertex is h and then negative 33. What we want to find is the h value. To do that, we take x squared plus 10x plus 8. And remember, if we set this equal to, say, y, then our objective is to get it in vertex form. So that means we put parentheses around our quadratic and linear term. The next step, write out x squared plus 10x plus blank plus 8 and minus blank. So if we, remember, if your a value is positive, then we're going to subtract at the end. Well, now we just do this completing the square thing that we did up here. We take half of 10, which is 5. 5 squared is 25. Oops, I'm sorry, that should have been minus 8. And now you can see where we're going to get the negative 33 from. The next step is to factor, meaning we get our quantity squared minus 33 here, because negative 8 minus 25 is negative 33. To get this binomial here, we take the square root, keep the sign, and square root. So it's going to be x plus 5, which means that h has a value of negative 5. Remember, switch, keep. So h is actually -5. All right, and lastly for this video, it says complete the square to write the quadratic function in vertex form, and make sure you show your work. So similar to how we just did for 4, parentheses around our quadratic and linear terms. We're going to need to put in our blanks. And remember, because a is positive, we'll subtract at the end. And then we take half of 3 and square it. So if you want to do it in your calculator, that's fine. It would look like that. 3 divided by 2 squared. Math, enter, enter. 9/4. Next, we factor. Square root, keep the sign, square root. So we will have x plus 3/2. If you're unsure of that, square root of 9/4. Math, enter, enter, will give you, oops, can't have that part under there. Got to hit the right arrow, and then math, enter, enter, will convert that for you, 3/2. And then we want to find this value, so we type in -9 minus 9/4, math, enter, enter, and get -45/4. Please remember that you are finding an equivalent form, which means we know how to verify this. If we type in x squared plus 3x minus 9, and then type in vertex form, and look at our table, our output values in our table should match. That's how we determine that two equations are equivalent, or two functions, okay? So make sure you're verifying it doing that step. B is going to involve an additional step. We still put parentheses around our quadratic and linear terms, but we must keep the -3, the a value, out in front of this quantity. So remember, when you're factoring something out, you simply divide the terms by that value. So we'll have x squared. Keep in mind this is -6x divided by -3, which gives us positive 2x. Now when we complete the square, we are going to have to add that number in, so we'll put plus blank. Bring down the +8. And remember that if your a value is negative, you will have to counter that by adding at the end. So just to reiterate, on part A value was positive, 1x squared. Since it was positive, we subtracted. For part B, since a is negative, we will add. Next, we complete the square. Half of 2 is 1. 1 squared is 1. But this is the kicker you got to pay attention to. When we distribute this, we get -3x squared, which is our original term, -3 times 2x, which is -6x, our original term. But -3 times 1 is really a -3 that was not there before. We still have the +8. This new guy, this -3, is what we have to take care of by adding 3. We want them to zero out. At this point, keeping our a, we can factor x plus 1 quantity squared, add at the end 8, 9, 10, 11, and then check to see if they are equivalent. So back to y1, -3x squared minus 6x plus 8, and -3 times the quantity x plus 1 squared plus 11. Our output values do match, so we should feel confident that we've got a good answer. Please don't forget that squared. Students love to leave that squared off sometimes. Don't do that. That concludes this video. I'll pick up with problem 6 in video 2.